Welcome back to our data analytics series. In today's video, we will explore one of the most critical steps in any data science project, exploratory data analysis, or EDA. This phase is where we truly begin to understand the structure of our dataset, discover patterns, and get a sense of the relationships between variables. By the end of this video, you'll be able to perform your own EDA and uncover valuable insights from any dataset. We will be looking at the following contents in this video. EDA helps uncover insights in your data through visualizations, statistical summaries, and analysis. Exploratory data analysis, or EDA, is the first step in understanding your data. It involves summarizing the main characteristics of the data using both visual and quantitative techniques. It's a preliminary step that helps us prepare for more advanced analysis. EDA is crucial because it helps you understand the patterns within your dataset. It reveals hidden relationships between variables, helps detect outliers, and guides further analysis by identifying the best modeling approaches. Skipping this step can lead to inaccurate conclusions. We begin EDA by summarizing the dataset using descriptive statistics. Key measures include the mean, which gives us the average value, the median, which provides the middle point, the mode, representing the most frequent value, and the standard deviation, which tells us how spread out the values are. Univariate analysis focuses on a single variable to understand its distribution. For numerical variables, we often use histograms, and for categorical variables, bar charts are effective. Bivariate analysis looks at two variables to understand the relationship between them. We can use scatter plots for numerical data or contingency tables for categorical data. Multivariate analysis expands this by examining more than two variables at once, often using pair plots to visualize relationships. Histograms are excellent for understanding the distribution of numerical data. They divide data into bins and show how frequently each value occurs in the dataset. Suppose we have a dataset of ages. To create a histogram, divide the data into bins. Example, 20 to 25, 26 to 30, 31 to 35. Count the number of data points in each bin. Plot the frequencies. Bar charts help compare the frequency of different categories. For example, if you want to compare sales across regions, a bar chart would show you how each region performs relative to others. Scatter plots are used to visualize the relationship between two numerical variables. They are particularly useful for spotting correlations, trends, or outliers. Suppose we are analyzing advertising spend versus sales. A scatter plot would show a positive relationship between advertising spend and sales. One of the primary goals of EDA is to detect patterns and anomalies in the data. Patterns might include trends over time or relationships between different variables, while anomalies could be data points that don't fit the general trend, signaling potential errors or rare but important events that require further investigation. Correlation analysis helps quantify the strength and direction of the relationship between two variables. The Pearson correlation coefficient measures linear relationships, where one variable increases or decreases in proportion to another. On the other hand, Spearman rank correlation is useful for monotonic relationships, where the trend is consistent but not necessarily linear. Pearson correlation measures the strength and direction of a linear relationship between two variables. The formula is given by this expression. The Pearson correlation coefficient are ranges from -1 to 1. A value of 1 indicates a perfect positive linear relationship, while -1 indicates a perfect negative relationship. Suppose we have the following data to calculate Pearson correlation. We use the formula and get R equals 1 indicating a perfect positive linear relationship. Spearman rank correlation is used when the relationship between variables isn't linear but monotonic, meaning as one variable increases, so does the other, even if not at a constant rate. The formula is given by this expression. Let's say we have two variables. We rank both variables and calculate the differences. Using the formula, we calculate. Our S equals 0.7, indicating a moderately strong positive correlation. When dealing with datasets that have a large number of features, dimensionality reduction techniques can help simplify the analysis. Principal component analysis, or PCA, reduces the number of variables by finding new axes that capture the maximum variance in the data. TSNE is another popular technique used to visualize high-dimensional data in 2 or 3 dimensions, making it easier to spot patterns or clusters. PCA is a powerful technique for reducing the dimensionality of a dataset. It transforms the original variables into new axes, called principal components, that capture the most significant variation in the data. This allows you to work with fewer features while retaining the key patterns in the data. TSNE, or T-distributed stochastic neighbor embedding, is another popular dimensionality reduction method that is especially useful for visualizing complex datasets. Unlike PCA, TSNE is nonlinear, making it better suited for plotting high-dimensional data in a 2- or 3-dimensional space to reveal clusters and patterns. Several tools and libraries can assist in performing EDA, especially in Python. Pandas profiling is an excellent library for generating automated reports summarizing your dataset. Seaborn is great for creating visually attractive and informative charts. And Matplotlib, one of the most widely used libraries, offers flexibility in creating both static and interactive visualizations. That concludes our deep dive into exploratory data analysis. Now that you have a strong understanding of EDA techniques, you'll be better equipped to explore your data and uncover hidden insights. In our next video, we'll move into statistical inference and hypothesis testing, two foundational concepts in data analytics. If you're finding this series helpful, don't forget to like, subscribe, and hit the notification bell so you don't miss any updates. See you next time.